what does modeling mean? So by modeling, we mean a mathematical modeling and also virtual modeling in this course, right? Mathematical modeling is a description of a system using a mathematical equations, differential equations, right? That describe the behavior of the system when certain input is provided. Why we need a modeling? If you deal with a very simple system, which is like a medical robots, right? Most of the medical robots, especially the one that we work at Children's Hospital, is very kind of, in terms of dynamics, very simple, because it makes sense, right? When you have a robot that interacts with patient, goes close to patient, you don't want to have a very fast and agile system, right? It should be slow so we can protect the patient. That's why in those kind of systems, dynamics is secondary. But when it comes to a robot like Atlas, and you want to have this robot do very precise performance like dancing or like backflipping, if you have seen the videos of the Atlas, you need to know about the dynamics and you have to model the dynamic of the system. In that case, you might be able to develop a robot that can dance as well as good as a human dancer, right? What I'm trying to say is that for a very complicated task, including dance, you need to have a very precise model of the system, right? And that model includes kinematic model and dynamic model of the system. Okay, modeling, we have a kinematic modeling and dynamic modeling. And each of those concepts, we have a forward and inverse. Forward kinematics, inverse kinematics, forward dynamics, and inverse dynamics. Most of the course will talk about the different type of the modeling, inverse, forward, dynamic, kinematics. So because of the different background, you're coming from different backgrounds, right? We have mechanical engineers, software engineers, and electro engineers. And some of you are very good at dynamics, kinematics. Some of you are better at programming, right? So the way I teach this course is based on this strategy. I assume that you don't have any knowledge in any of those fields, right? Otherwise, it's going to be very complicated, which is not the case, right? I'm sure that at least you have some knowledge or maybe a lot of knowledge in one of these aspects. And then in chapter 1, which will maybe take 2 sessions, I'm going to give you very overall view of all the topics: kinematics, dynamics, virtual model, and also control. And I'll ask you to complete Project Zero. Once you complete Project Zero, you will have a very good overview and you will have the big picture of what you are expecting next. And then in chapter 2, I'm going to dive into the same topics, but we'll cover more advanced material, right? So then you can relate to the previous chapter, and it will hopefully help you to understand and implement Project 1. Again, in chapter 3, I'm going to again cover advanced topics, not advanced, but more technical concept for each of those categories again. And you will have a half semester from Project 1 to Project 2 to come up with a cool idea and implement kinematics modeling and virtual modeling and control on that system. And between projects, we are going to also release 4 or 5 homeworks, which are less intensive and less time-consuming. The homework are designed to help you to, again, practice the concepts and have a better understanding of the topics before kind of working on the projects.